Good morning. It is Friday, the 11th of December. I was so confused yesterday. Like in the afternoon, I suddenly realized that it's Thursday and not Wednesday, which was great. I discovered it was close to the weekend, and I thought last Sunday I was absolutely convinced it was Saturday. That was less great to discover that it was not, in fact, Saturday. Um, yeah, today we got, I think, a cool puzzle. Um, Looks like a variation of Game of Life, Conway's Game of Life. I've done Game of Life, of course, a number of times in different renditions. Uh, the fun thing with this is that you can do really fun visualizations of it. So I did, for instance, a Conway Game of Life in Minecraft recently. Um, and maybe I'll get to doing something similar today, but I think I'm first gonna just focus on finishing the first part, just to see how hard the second part is. Because yesterday that was a little bit of a bummer. That the second part, well, yeah, I didn't in the end. So yesterday I failed to do it on stream. I did come up with a solution in the afternoon after letting it simmer for a little bit. That ran within a couple of milliseconds. So and a lot of people have reported some very fast solutions and some very compact solutions. Yeah, it seemed like discrete math combinatorial problem. And again, as always with these Game of Life things, right? Like if you can figure out the computer science concept or the math concept that they have in mind, then you got your solution ready. But if you're just sort of trying to figure it out from first principles, sometimes it's not trivial. Not a ton of comments. I think I just want to dive in. Actually, let me make my font a little bit bigger. Also, yeah, someone suggested using this keycast and keycast mode. Yeah, so see how that shows in my mode line what I'm typing. Hey, 2 people on stream. Welcome to Lemon Island and Event of Code in Clojure. So yeah, I just want to make my font a little bit bigger. Do we get keycast mode in here now? No, I need to enable it in every buffer. No, still not. Oh, now it's enabled. Okay. Yeah, so that was a suggestion because I tried this screen key that did not work for me. Now I did notice with this. Oh wait. Oh wow, this is doing something weird because I'm in insert mode and now I'm not. Oh no, I am, but my cursor doesn't show. So. Okay, that's a little strange, a little confusing, but I'm okay. The other thing that I noticed with this keycast mode is that, say I have a couple as expressions, and now I do, I'm gonna do 3D capital L, which means 3 delete as expression. So this is Vim style and evil style. Now 3, okay, that's numeric argument. You see what that does. D, evil delete. But then L, it doesn't even show, right? Because it's consumed by the delete comment. So, but okay, you should get a slightly better idea of what I'm doing. Yeah, my solution for yesterday, puzzle 10, you can find it in GitHub if you're curious, kind of to this divide and conquer approach. But have a look at the Advent of Code channel on Clojurians if you want to see some very clever solutions. Point being, I did eventually get my second star. And don't we all just want the stars? Okay, so story goes, our plane arrived, we're at the airport where we're making a stopover. No, we're at the final point where we need to take a ferry to get to the island. And there's a waiting area with a bunch of chairs. And so our puzzle input is the layout of this thing where L is an empty chair and period is the floor, so no chair, and pound or hash is an occupied chair. And that's basically, you know, I don't, the rules are probably slightly different, but it's very similar to Game of Life. If there are no occupied seats, then it adjacent to the seat itself, then it becomes occupied. If the seat is occupied and 4 or more seats are occupied next to it, then it becomes empty. So this is, I think, what the Game of Life calls starvation. If it gets too busy, it's like, I'm out of here. Otherwise, the state does not change, and we need to find a fixed point. So we just need to run a number of generations until this thing no longer changes, and then we need to count the number of occupied seats. So like I said, I think I'm just kind of gonna try to fly through this first part fairly quickly, just to see how hard exactly the second part is. Yeah, let's say string, split lines. Yeah, for these things it is handy, yeah? So this is, I have a comma prefix, and then a bunch of stuff underneath there. So comma R AM is comma refactor add missing, and then you get CLJR add missing. So split line, demo input, yes. And then I'm just gonna map that with a map. So we only have to care about 2 cases, the period and the L. And I was thinking of maybe just using symbols here. Why symbols? Just because it kind of looks nice when you print it. Yeah, and L is fine. L is L. Well, map over map. So I actually want to map V, the outer thing, and then map. Yeah, I want to use vectors, not just sequences. Like this, right? Is that correct? That is correct. So that's our layout, and that's, yeah. So this way, you know, it'll be nice. So like I said, if part 2 is not too hard, I want to see if we can do some more fun visual representation, some graphics of this thing. Yeah, let's first just focus on solving it. No, we don't want side results on this side. Yes, there you go. And then we just need to count. So given define count occupied seats. Yeah, what are we going to use for occupied seats? Because I don't think pound is a valid symbol, but we can maybe use O. Is that nice and visually distinct from L? Good enough. Count occupied seats given the current layout, and X and Y. Yeah, and then we just say for X range okay, let's first focus on, because we need to deal with the edges, right? So we actually need to know what our max indexes are. So in this case, max X is count first, demo input, still doing Lisp. No, not even. Kind of support on character on. Oh yeah, there we are. Layout. The first layout. Let's build this up in small parts. Haha! Were you planning to share your screen? Okay, it happened again. This time I did not put my post-it. Oh, I'm so sorry, folks. All right, here we are. Let's just start over. All right, so that first person on the stream did not deem us worthy of leaving a comment that I was not actually sharing my screen. Okay, so what I was doing before, basically split lines of this demo input, and then gonna map v over that to get vectors, and then we're gonna. So now we're mapping over strings, and then those strings we turn into vectors. Like I said before, let's actually quote this whole map. Periods will turn into symbol underscore, and else will turn into an L symbol, so that looks like what you see on the right. Well, now I'm double quoting it. I was quoting the map, so I didn't have to quote the inner ones. There. So this is our layout, def layout. And then let's first define max x and max y. Max y is easy. That's just the amount of rows that we have. Actually, it's one fewer, right? If we have 10 rows, then the maximum index is 9. And then here, decrement of the count of the first of the layout. Okay, so 9 and 9. Yeah, that seems about right. So because get in layout 9, 9, we still get something, but 9, 10, we get nil. Yes. Then neighbors. Given x, y, max x, max y, let's just return basically all the different pairs that are valid. Just gonna reuse x and y here. I think that's fine. So yeah, we'll do a range, and then the maximum of 0 decrement x. Right, so basically I'm decrementing x, but if it's 0, it'll stay 0. And then and then the min, so kind of doing the opposite thing, max x inc x. So I'm basically getting a range from decrement x to increment x. Let's start with that. So now I should be able to evaluate this. 4, 5 plus 2x. 4, 5, 6. Yes. So we have a range of 3 with 5 in the middle. But if I do this, for instance, with 0, then it's just 0, 1. And if I do it with 8, 9, then it's 8, 9. Yeah? No, it's just 8. Uh, right, yeah, so no, it's actually it's here that I need to increment, so it is increment instead of +2, which makes more sense. But the range is exclusive the boundary, the end boundary. So we need to increment that again to get it inclusive. 8, 9. Yeah, and this still works. If I do 4, we get 3, 4, 5. Yeah, and then I just basically do the same thing. Actually, to y capital L to copy two as expressions. And then let's change all x's to y's in this line, which almost works, except max becomes may. And then x, y. Define, of course. So, neighbors of 5, 5 given max of 10, 10 should give us everything from 4, 4 to 6, 6 and everything in between. Yeah. So 9 combinations, right? Oh, actually, yeah, but we only want the neighbors. We don't care about the seed itself. Okay, so in this case, I do actually need to name these different. I'm just going to call these x prime and y prime. That's what that little quote at the end of a symbol is called usually. When not equals x prime, actually, yeah, no, not and equals x prime equals y prime. Yeah, neighbors. So now we get 8 results, which is exactly what I want. So everything should be in there from 4, 4 to 6, 6, but not 5, 5. And if we do this on the boundaries, yeah, then we only get 5, right? Like 6 minus 1, because we're on the edge. If we do it in the lower left corner, we should only get 3 results. Yeah, those are our neighbors. And then we need to I call it post score, position score. So we have a layout, we have an x and a y, and yeah, let's pass those max x, max y around. Although, I mean, I'll use the global ones for now, but eventually I think we want to pass those explicitly. And yeah, this becomes just this, I guess. So reduce neighbors x, y, max x, max y. Score starts at 0. Score x, y. Get in layout. And actually then I don't even need to destructure this. I can just call this cohorts. Get the cohorts into the layout. And then again, we'll map these. And there's only 3 options really. Underscore, that's a floor, that's 0. An empty seat, that's 0. If it's an occupied seat, that's 1. I guess we could also just say if O, then it's 1, otherwise it's 0. If 0, 1, 0. Okay, now pulse score layout 5, 5. It's going to return 0 because it's, you know, it's always 0. But if we say we change, wait, which, okay, now let's actually say that we do an assoc in layout 4, 5, and we change that to occupied. So it's in, still 0. Even though we have one occupied seat. Does anyone see it? So neighbors 5, 5, max x, max y should contain 4, 5. 4, 5's in there. We need to add those together. Score. What does map v with this quoted map do? I mean, this is yes, this might look a little bit unfamiliar, but it's basic Lisp stuff. So what does this do? You know, this returns a map with the character period with the, as a value, with the key being whatever the value of the underscore variable var is, because this is a symbol, right? And like normally a symbol would interpret to looking up a var with that symbol name. And all I'm doing is saying like, okay, well, this form, don't evaluate it, you know. So it's equivalent to just doing this, you know, like, so maps evaluate themselves, characters evaluate themselves, but symbols evaluate to variable lookups, and we don't want that. We want the actual symbols. So I'm just quoting it. That's all there is to it. Yeah, so now we should get 1, right? Exactly. Let's try a couple more. So yeah, if we change the seed itself, that should not impact its score. But if we change some other stuff around it, that should. But if we change a value that is not within that range, then that should not influence the score. So now we can implement our generation function. Is this a good name? I don't know, but you can, you know, like in Game of Life they call these generations, right? So these iteratively changing the thing. Layout. Yeah, just layout. Well, again, max x, max y. Eventually I'm going to compute that up front and pass it all around, but right now we just have those global variables, which is fine. Yeah, can we, I mean, I'm tempted to do a for loop, but then we need to coerce everything back to vectors. And actually it would have to be a nested for anyway. Whereas if we stay with map v and say range, so yeah, first the rows are the first level, right? Row map v range max x call, or in particular, well, this is not, because row might make you think that it's a vector that we're getting there, but no, we're getting a number. So this is x and y. let's already try that. So now we should get again a 9 by 9 vector, right? Just making sure that I got that right. Doesn't do anything with that yet. Yes. And then we say get in layout. YX, right? But then, okay, see, I think I'm messing things up already. Do we call the rows X or do we call the columns X? I mean, the rows should be called X. I think that's the most logical, that you grow from the top left bottom towards bottom right. Yeah, so it's actually X, Y here, and then what we had before, I think, does still make sense that a coordinate is X and Y in that order. So let's see. Let's just do a case on that. We got 3 options. If it's a floor, then it remains a floor. If it's an empty seat, and here we have to check the rules. If it's an empty seat, and there are no occupied seats adjacent to it, the seat becomes occupied. So if 0 position score layout XY, then it becomes occupied, otherwise it remains empty. Not sure why are they using L for empty. Like, as a Dutch speaker that makes sense, but it doesn't make that much sense in English. But okay. And then if it's occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. As I mentioned before, I like to prefer the smaller than, because then you just have to think that the numbers in this range here are, or in this expression, need to be going up from left to right, which I find more intuitive than the other way around. So if there are 4 or more occupied seats, then this one becomes empty, otherwise it becomes occupied. Oh, case, yes. Case is a bit of a weird one, huh? But I don't think in this case it's gonna say, no, does that actually work? Yeah, so the thing that you match against in a case are not evaluated as such. I think that is right, actually. Generation led, okay. So yeah, let's see. So we had this as our starting point, and now after one generation, everything's occupied. And is that? Yes, that is also what they are getting. Where then after one generation later, it's mostly like on the left and on the right and not so much in the middle. Do we kind of see the same thing? No, that's a little different. Like, for instance, this L here, they don't have that. And that's this guy, which means its score should be 1, 2, 3, 4, 5. Oh yeah, so no, I did mess it up here, right? Is that right? Ah yes, okay, this looks more like it. The sides are occupied, plus a couple more. This one is that. Do we? But this one should also be occupied according to their example. This one's score is only 3 though. Oh yeah, it's only 3. Yeah, exactly. It's only 3. So we have that generation, that layout where everything is occupied, all the seats are occupied, and then row 9, position 3, right? No, 2. 0 index. That is 2. And 2 is smaller than 4. So this should have become empty. Oh no, it is. Why do we get a different result? Wait, is this? Now I'm. You know, it should. If seat is occupied and 4 more seats adjacent to it are also occupied, the seats becomes empty. Otherwise, the seats change does not change. Okay, yeah, this one has. Hey, Sebastian, good morning from Berlin. So this one has 3 seats around it which are occupied. So yes, it should remain occupied. And so the score for it is, but the score for it is 2. How is the score for it 2? Are we looking at the right one? Oh. Oh, we only. Oh, wait a second. Haha. We are shrinking our. That's cute. Yeah, okay, so max x max y is the maximum index and it's not the count. That makes sense. Off by 1 errors or fence post errors, they are a thing. No, decrement, increment. Wait a second. Okay. Yeah. So on the side, then this guy's still occupied. There's a couple here occupied. That is exactly what we're seeing here. And now we just need to find a fixed point. So defn find fixed point layout. And now I'm gonna do the max x max y stuff in here. Oh yeah, actually I also, let me already grab the puzzle input for day 11 because I kind of want to look at that and see how big that is. No, 11. Yes, puzzle input 11. Yeah, that's sizable, but should still be able to maybe visualize that later on. Not too horrible, right? Also, in terms of processing, I think we can easily handle that, at least for part 1. So, I mean, I could do an iterate, always fun. but I'm actually just gonna do a loop recur. But first we need to compute the max x, max y. Splice, splice, for slurp. And then let's loop. Layout. Let's say layout prime layout. Layout prime generation layout, so that they're not the same. If equals layout. Yeah, we still need to be able to count, but that should be, I'm just going to do that inline, so that the result is, well, let's first just find the fixed point. I mean, either they're the same. If they're not the same, then recur generation layout. Yeah, and so now we're gonna start max x, max y. I'm gonna add an extra arity version here, so that I can still use the global ones. So these are then just going to use these global vars as arguments, so that I can still call these things from the REPL without having to specify all this stuff. And this is a pattern I'll sometimes do. You also see that in the Minecraft API we've been working on, that like a lot of these functions you can pass the stuff very explicitly, but if you leave it off, it'll just take, you know, for instance, the current player position or something like that. So and so in real production code, you generally want to have everything explicit, but then when you're poking at it from the REPL, it's kind of nice that it just takes some sensible defaults. Layout XY, this one takes a few more arguments. And then here where we call generation, we do want to thread that stuff through max X, max Y. I'm getting to a lot of positional arguments here. Maybe there's a case to be made for starting to stick this stuff into a map, so you can just sort of pass a state map around. I mean, these are 5 positional arguments. That's already pushing it, I think. But okay, you know, it's advent of code. So let's see if we can now find a fixed point for our layout. Ooh, no, this looks like it's... Wait, is it running? Yes. Continues for 3 more rounds. To stabilize and further application of these rules cause no seats to change state. Once people stop moving around, you count 37 occupied seats. After, what is it? 1 generation, 2, 3, 4, 5. So if I iterate generation layout, yeah. Oh, yes, good point. Of course, I need to... There you go. Thanks, Alexander. Yeah, so I called this layout prime so that I would have a separate name so that I could compare it to the previous version, but then I need to make sure I have the previous version and not just... and also here, like this, right? I mean, layout prime, these prime names, maybe that's not actually that clear, but okay. Find fixed point works now. 1 millisecond. Let's hope that's good enough. And then we just need to say, I think I can actually transduce this one mapcat seats count as 0, floor counts as 0, empty seat counts as 0, occupied seat counts as 1, and then we add those together. 0. Oh. Right, because this is, no, I need, it's not mapcat, it's cat map. Is that right? So if I first concatenate these inner vectors and then map over them, now we just get a lot of nils because I'm using characters where I intended to use symbols. So it's, I don't use a lot of commas, but in this case, yo, that looks better. Okay, 37, and that is indeed the result. Let's call this parse input, parse input, demo input, demo layout to be particular, relayout, parse input, slurp, yeah, just gonna IO resource, puzzle input 11.text, add missing, does that work? Do we get something that looks, yeah, now the pretty printing. We could set a wider miser width, I think that it's called in pretty printer terminology. Yeah, and then let's give this also a name. Result 1, I guess, because it's puzzle 1 of the 2. Layout. So can we say result 1 demo input? Well, let's call it demo. No, not demo input, demo layout. Demo layout. Come on. Hermitage 37, yes. And then the real one 33. Okay. Somewhat anticlimactic. 33 is not right. Oh. That is very inconvenient. It works. Yes. That's of course what you need to watch out for with the thing that I'm doing, because I have a global max x and max y, and generation doesn't need them explicitly. You can just pass them in. I thought already that it seemed like a low number, but that makes sense. Ooh, this took a little while, but not too bad. How long does this take? second and a half. But that does not bode well for part 2. We might need to improve our algorithm a bit. 2552. What? Jesus Christ. I'm gonna restart my REPL just to make sure I don't have anywhere else where I'm accidentally using these global ones. Yeah, so that's the thing. Where like I'm calculating them and passing them all through. So yes, they definitely should be. So we're taking them here now explicitly as arguments. We're taking them here explicitly as arguments. We're passing them through as arguments. And we're calculating them at the start and passing them all the way through here as well. No, still 552. You guessed 2552, and it's not 2552. Bummer, eh? Okay, what's the difference between the real layout and the demo layout? Oh, I'm computing. Am I computing them? No, I'm computing them the same way I was computing them before. I mean, it works for the demo layout. Yes. Yeah, so people joining the stream, where we are is that I thought I had a solution for part 1. It works on the demo input. Get 37, that's what we're supposed to get. But on the real input, it fails. Let's first make sure that we're not, as before, changing the size of our thing. Layout size L, count L, count first L. So the size, layout size 97, 98. That already seems dodgy, because you would expect they would be square. Are we parsing right? Yeah, so the size doesn't change, that's fine. Puzzle input has 97 lines. Oh my god, is it the new lines? No, max X should, max Y should, I mean, they don't change for a given layout, no. I just want to compute them up front so I don't have to compute them everywhere, so I compute them and pass them all around. Okay, if string split lines first count, that is 98. So yeah, 97 or 98 appears to be right. Let's Pragmata Pro. What is Pragmata Pro? Just gonna write this to a file and then rely on Emacs's auto refresh so we can kind of see. I think that's not a terrible way to see what's happening here. That seem reasonable? Map over this like that. Okay. Split layout. Actually, yeah, that way we can also compare. Oh, so this font is Iosefka. Benjamin seems to think that it's something else, but this is Iosefka. Been a common question already. Seems people really like it. Okay. Well, spit should take the file first, right? Okay. Temp layout.txt real layout. Let's open that here. Yeah, so this is what we have, and if I make this a little wider, then I should be able to do this. Yeah, did anyone get the Cyberpunk game? Yeah. I mean, that looks, after first generation, everything's occupied. Because all the seats are empty. Now, the other thing that I'm curious about is, yeah, no new line at end of 2 max y on one line instead of max x max y. Is that right? Do we have a max y? Oh my. Well spotted. Thanks, David. Someone's paying attention. Still 2552 though. Sure, that counts. Is there anywhere else where I'm messing up my max x's and max y's? Max y, max x, max y, max x, max y. Inside generation. Yeah, you're right. I see. I was confusing myself when we were writing this function. And of course this works because no matching clause. Okay, we need to get it straight. So my x should be horizontal. Yeah, and so in that case here, no, like this should be max y. Max y is y already. But if y, no, that's also not right, because then all my get-ins should be around. So yeah, I definitely have places where I'm swapping x and y. And I think it works because the... So okay, if we agree that get-in takes coordinates x first, then x goes down and y goes to the right, even though that's kind of counterintuitive because usually the horizontal axis would be x. So that's kind of how I'm confusing myself. But yes, then the outer loop should loop over the x's, i.e. the rows. Maybe I should have stuck with row and column, and they should loop over the y's. But now, is there anywhere else where I am sort of messing up that? Because now this works, but this errors, no matching clause. Probably because I'm getting something outside of my range. Yes, so now exactly I need to swap these two. So yeah, I picked my x and my y terribly. Hey Vincent. And that explains my confusion. All right, we got a new number, 2472. Would that be correct? Well, it's an hour in and we're all still at part one. I thought part one would be like, oh, 5 minutes and we're through. Okay. Part one. I made it harder than necessary and confused myself. Let's see if we can still get part two. As soon as people start to arrive, you realize your mistake. People don't just care about adjacent seats, they care about the first seat they can see in each of those 8 directions. those 8 directions. Which 8 directions? Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in each of those 8 directions. For example, the empty seat below would see 8 occupied seats. Right. The leftmost empty seat below would only see 1 empty seat, yes, but cannot see any of these occupied seats. So no occupied seats. Yes, okay. Right. Yeah, gonna be a question, right? If it's gonna be fast enough, do we have to do something smart to compute this stuff? Or can we really just for each seat? I mean, if for each seat we're gonna, sort of iteratively go into these 8 directions, I'm afraid that's gonna blow up in terms of computational complexity. So can we instead sort of do a single pass over this? Because I mean, my naive approach would be so similar to what we do now, right? Like we take a position, calculate the neighbor indexes, neighbor coordinates, look at what's there, add those together. But now we would have to start from a position and then do 8 separate iterative searches until we hit either an empty seat or an occupied seat. I mean, there might be some memoizing that could help to an extent. Yeah, let's come up with a first, albeit naive solution. And streams dragging on part 2, and then we'll see if that's good enough. And if not, I think I'm going to do the same thing as yesterday. Take a step back, maybe have a go at a smarter solution in the afternoon. So how much of this can we reuse? Not a ton. No, not even. Well, generation, yes, but we need to change how the score is calculated. Let's pass generation in, because I guess we're still looking for a fixed point, right? Yeah, we're still looking for a fixed point, so this is all still the same, but I'm going to pass in the function. You think so, huh? I don't think so. But you dropped in neighbors later. So neighbors really just only computes pairs of coordinates. It doesn't really check the map at all, and we do need to check the map for this because we kind of need to terminate early. You're saying for part 2, is it a rule? Is a rule changed? Ah, yeah, now it takes 5 or more visible occupied seats. I'd missed that part for an occupied seat to become empty. I mean, I guess one optimization that takes 5 or more visible occupied seats for an occupied seat to become empty rather than 4 or more than the previous rules. So yeah, we need to check in 8 directions. And so we get a score between 0 and 8. Now, as soon as we get a score, as soon as we've seen 4 empty seats, we can terminate early. So that could shave off a little bit of the time. Okay, so I think this way we can reuse find fixed point, compute max x, compute x max y are all good, but pulse score and generation yeah, I'm not sure just adjusting neighbors is gonna be a fruitful approach. But yeah, so generation 2 can change the same if we change this and change this into a pulse score 2. But that limits our ability to terminate early. Okay, I'm gonna do this. Although all that restructuring probably also isn't gonna help our. No, I really hope. I feel like I kind of want to take a step back and go back to some first principles. In particular here, okay, so let no sim, because we don't know if it's a seat, could be a seat. If it's empty, then it stays empty. Else, compute seat layout xy max x max y. I don't know if this is going to be fruitful, but we can define something like this. Actually, we can just do this for range 2 y. No, actually, can I go from -1? Equals x y 0 0 x y. So these are the 8 cardinal directions. And then seat in direction, layout, max x, max y. And just gonna do some more loop recurring, never hurts. Oh, x, y, max x, max y. Layout, direction. Gonna add a clamp helper to make sure those don't. Actually, no, no, not gonna do that. Just gonna do if or x smaller than 0, y smaller than 0, max x smaller than x, max y smaller than y, 0. Actually, and if let's see it get in layout x y, cont no case seat, if it's an empty seat 0, if it's an occupied seat 1, if it's the floor, then we recur with plus x dx plus y dy. So I hope that's kind of clear what I'm doing here, right? Let's test this. So yeah, they gave an example. So say we have something empty seat, floor, occupied seat, whatever. So this is seat 1, 1. Seat in direction. This is our layout. Given seat 1, 1, max x, remember x are the rows, highest row index is 1. How many do I have here? Okay, 1. How? Doesn't like that? Oh, yeah, no, it doesn't like that. We are using O. 7. 1, 7, and a direction, and remember that x goes down, y goes right. So this should return an occupied seat, but if we go the other direction, then it should return 0, or if we go up, then it should return 0. But if we turn we turn this into an occupied seat, and we get a 1. I think that works. And now I'm gonna say compute seat, and compute seat. What did I have here? 5YL. Actually, let's, in this case, reduce over these directions, starting from 0. I call this other thing seat in direction. Seat in direction. Layout XY max X max Y direction. And then actually because I'm not making a distinction between empty seats and occupied seats in the sense, because I want to be able to terminate early here. I don't want to go over all directions. Well, okay, let's just do it. Let's not do that then first. Let's just say, I mean, this is really the basic, right? Like, so let's see, what example do they have from their, the empty seat below would see no occupied. Well, I think this should already be enough for a naive solution, but it's not going to be fast enough. I'm pretty sure it's not going to be fast enough. Does that work? Didn't I change this? No, I changed my find fixed point, but not my result 1. Matching clause 0 over here. No, that's okay. I'm going to reevaluate the buffer because my line numbers are starting to drift because I've been making all these changes. Yeah, 2 people left on stream. I guess this is the less interesting part. Okay. Yeah, because no, and here we need to apply the rule, right? And here, okay, yes, and in that case we can actually. So as soon as we reach 5, we can return an occupied seat. Yeah, it's also kind of weird because now we're either compute. Yeah, okay, let's just say as soon as we reach 5, you know, we return that. Otherwise, we continue to do that, and then yeah, we can. And then we really only need to make the distinction between 5 or not 5. Because we don't count beyond 5. If we get to 5, we're like, okay, that's good enough. That's an occupied seat. That's an empty seat. Zero. Great. Let's check our compute seed. So if you say, oh wait, no, if it's, there's still the 0 rule, because now seats never become occupied. So either it's 5, then it becomes occupied, or it's 0, then either it's 5, then it becomes empty, or it's 0, then it becomes occupied, and otherwise it just stays what it is. That's correct, right? Mitesh, you're still following at home? Okay, that looks better. 26. 3 milliseconds just for the demo layout. Oh, okay. We have a result. Is it the result? 2,197. Oh my, wow. Surprise. Thought it would be again like, you know, just spinning for hours. All right, sorry folks. I see a bunch of people dropped off halfway. I mean, folks have other stuff to do. I get it. The video will be up. Hope there was some interesting stuff in there. So thanks for watching, and hope to see some of you tomorrow. Have a nice day.